Have you ever wondered how a star is born? Like everything else in this vast universe, stars too have a beginning, a middle and an end. Their story begins not in a fiery explosion or a brilliant flash, but in the quiet, cold corners of the cosmos. Our journey takes us to the birthplaces of stars, the molecular clouds. These are not your everyday clouds that you see floating in the blue expanse above. Oh no, these are cosmic nurseries located light years away in the depths of space. They are dense and cold regions, far colder than any winter you've experienced on Earth. Imagine these clouds as humongous swirling mists of dust and gas, primarily hydrogen. So what makes these clouds special? Well, it's their density and the sheer amount of material they contain. They are the perfect breeding grounds for star formation, with their rich reserves of gas and dust serving as the raw ingredients required to cook up a star. Now you must be wondering, how does a cloud of dust and gas transform into a brilliant shining star? The answer lies in the delicate dance of forces at play within these clouds. The immense gravity of the molecular cloud pulls inwards, condensing the dust and gas. On the other hand, the pressure of the cloud's gas pushes outwards. This delicate balance sets the stage for the birth of a star. So picture this, a molecular cloud, a cosmic cradle, tucked away in the distant reaches of our galaxy. It's vast and cold, swirling with dust and gas. And within this cosmic cradle, the first stage of a star's life begins. In the heart of this cloud, under the immense weight of its own gravity, a small part begins to collapse. This is where our story takes a turn, where the calm gives way to a cosmic commotion. This is where the birth of a star truly begins. And within these cosmic cradles, the first stage of a star's life begins. The birth of a star begins with a simple yet profound event, a collapse. Now, this isn't a collapse as we would typically imagine. No, this is a celestial event of grand proportions, taking place over thousands of years. Within the vast cold expanse of a molecular cloud, pockets of gas and dust become denser under the relentless pull of gravity. But gravity isn't the sole player here. The pressure and heat within the cloud resist this gravitational pull, maintaining a delicate balance. Yet, every now and then, a disturbance tips the scales. Perhaps a nearby supernova explosion, or the turbulent motion of the cloud itself. And so, the collapse begins. As the dense pocket within the molecular cloud succumbs to gravity, it forms what we call a cloud core. Picture a swirling mass of gas and dust contracting under its own gravitational tug. As this core shrinks, it grows denser and hotter, and in this process known as accretion, the core continues to gather material from the surrounding cloud. It's a bit like a celestial snowball, gaining more mass as it rolls down a hill, except this hill is the vast landscape of a molecular cloud, and the snowball is a growing ball of gas and dust. This collapse isn't a quick tumble. It's a slow, relentless process, taking anywhere from a few thousand to a million years. The cloud core continues to contract, growing denser and hotter, its gravity becoming ever more potent. The gathered material forms a swirling disk around the core, a cosmic carousel of gas and dust, spinning and spiraling towards the core. And so, the stage is set. The cloud core's collapse leads to the formation of a swirling disk of material, a disk that will feed the growing core and contribute to the birth of a new star. The relentless pull of gravity, the dance of gas and dust, the heat and the pressure all play their part in this cosmic ballet. This collapse sets the stage for the next phase in a star's life. As the cloud core continues to collapse, a new entity begins to form, a protostar. This is the point where our journey gets particularly fascinating. You see, as the core of the cloud collapses under gravity, it begins to heat up, giving birth to a protostar. Picture this, the core is a ball of gas and dust, shrinking and growing denser. As its density increases, so too does its temperature. The heat is generated by the conversion of gravitational energy into thermal energy, a process known as Kelvin-Helmholtz contraction. This is the protostar's primary heat source until nuclear fusion begins. Now, you might be wondering how a protostar grows. It's a process we call accretion. The protostar, with its intense gravitational pull, attracts the remaining gas and dust within the molecular cloud. This material spirals inward, forming an accretion disk around the protostar. As this material lands onto the protostar's surface, it delivers not only mass but also additional energy, causing the protostar to shine brightly. But hold on, it's not all smooth sailing from here. Protostars go through a rather turbulent phase known as the T-Tauri stage. During this period, strong winds are expelled from the poles of the protostar, often resulting in the creation of beautiful and complex nebulous structures known as Herbig-Haro objects. So there you have it. That's how a protostar is born and grows. From a dense core of gas and dust, collapsing under the weight of its own gravity, to a glowing ball of gas, accumulating mass and energy from its surroundings. It's a process that takes a few 100,000 years, yet it's only the beginning of a star's life. The protostar phase is a turbulent time in a star's life, a time of rapid growth and change. But as we'll see in the next scene, this is just one step in the fascinating journey of a star's birth. As the protostar grows, it faces a constant struggle, a battle for equilibrium. In the heart of this celestial infant, a tug of war is underway. On one side you have gravity, tugging everything inward. It's the force that brought our protostar to life, compressing gas and dust together. But there's a catch. As gravity pulls inward, it makes the protostar denser, hotter, and that's where the opposing force comes in. Pressure. Pressure is the rebellious teenager of our cosmic tale. It doesn't like being pushed around. So as gravity increases, so does pressure, pushing outward against the force of gravity. This struggle, this battle between two titanic forces, is the core of a protostar's journey to becoming a star. Now, if this was a simple tug of war, we might see the protostar collapsing back into a cloud of dust or exploding outwards. But this is where the magic of star formation comes in. As the protostar's core gets hotter and denser, something extraordinary starts to happen. Nuclear fusion. Nuclear fusion, the process that powers the sun and all other stars, begins to take hold. The temperatures and pressures at the heart of the protostar become so intense that hydrogen atoms start to fuse together, forming helium. This process releases a tremendous amount of energy, radiating outwards as light and heat. This is the first spark of a star's life, the first light in the darkness. But this isn't the end of our protostar's journey. Quite the opposite, it's just the beginning. The energy from nuclear fusion increases the pressure even further, pushing back against the force of gravity. This delicate balance, this dance between gravity and pressure, will continue until they reach a state of equilibrium. When equilibrium is achieved, the protostar has reached adulthood. It has become a star. The protostar's struggle for equilibrium culminates in its transformation into a main sequence star. The journey of a star doesn't end with the birth of a protostar. This is merely a prelude to the main act, where it becomes a main sequence star. The magic truly begins when the core temperature of the protostar reaches a staggering 10 million degrees. At this point, something remarkable happens: nuclear fusion. Nuclear fusion is the process that powers a star, the very heart of its existence. It's here that hydrogen atoms come together to form helium. And in this fiery dance, an enormous amount of energy is released, causing the star to shine brilliantly. This is the moment our protostar graduates to become a fully fledged main sequence star. But what does it mean for a star to be in the main sequence phase? Well, think of it as the star's prime of life. It's a period of stability, a time when the star settles into a state of balance. The outward pressure created by the nuclear fusion in the core is perfectly counterbalanced by the inward pull of gravity. This delicate equilibrium allows the star to shine steadily and can last for billions of years. During this time, the star is primarily burning hydrogen into helium in its core. This process, which is essentially the star's fuel, keeps it shining brightly. However, like all good things, it must come to an end. When the hydrogen supply in the core starts to diminish, the star begins to evolve out of the main sequence. But let's not rush into the future. For now, our star is in its prime, radiating energy and bathing its surroundings in a warm, celestial glow. It's a beacon of stability amidst the chaos of the cosmos, a testament to the power and longevity of nuclear fusion. And so, the star shines brightly, a beacon in the vast expanse of space. From a humble molecular cloud, through the stages of collapse, accretion, protostar development, and the struggle for equilibrium, a star is born. It's a process that takes millions, if not billions of years, and is happening right now across the vast expanse of the universe. Each star we see in the night sky has undergone this incredible journey, and each one tells a unique story of cosmic evolution. It's a captivating process, filled with awe and wonder, a testament to the majesty of our universe. And while we've covered the basics of star formation today, there's still so much more to learn. The universe is vast, and its mysteries are numerous. Each new discovery, each new understanding brings us one step closer to unraveling the cosmic tapestry that is our universe. And that, my friends, is the captivating story of a star's birth, a journey from cosmic dust to stellar dazzle. We hope you've enjoyed this journey through the birth of a star. It's a fascinating tale of cosmic evolution, one that we're thrilled to share with you. If you found this trip through the cosmos informative and interesting, we encourage you to like this video and share it with others who might also enjoy a voyage among the stars. Your engagement helps us to continue creating these videos and sharing the wonders of our universe. And if you haven't already, do subscribe to our channel for more such educational content. We've got plenty more cosmic stories to tell, and we'd love for you to join us for the ride. For those of you who want to stay updated, consider following us on our social media platforms. Thank you for joining us on this cosmic journey. Stay curious, stay inspired, and remember, the universe is filled with wonders waiting to be discovered. Until next time, keep looking up.